Okay, so what I'm going to be recording now is setting up Groot2 and then hopefully designing the behavior tree, and then I'll record the other parts of the tutorial later on. So for now, how do we set up Groot2? Basically, you have to go to Files directory, and then I haven't included it as part of the Nova workspace. You can find the thread in the software channel on Slack. Okay, so before we get into designing behavior trees and testing them, we actually need to first install Groot, which is basically like a visual editor for behavior trees. Now, eventually it's going to be merged into master, but for now you can find Groot in feature/Groot or feature/BT, which has been rebased off feature/Groot. And the way that you install it is you have to go to Nix files, Nix build -a packages, and the name of the package is Groot2, and then you can just build this wherever you want. I'm going to put it for now, and go ahead and do that. For me, it should be really quick because I've already built it before, so yeah, it should already exist in the next door. And when you go to your builds folder, wherever you build it, in that build result should be the binary, and in the binary there should be an executable. So if I run this, Groot2 should launch, hopefully. Oh, nice. Cool. So I think what I might actually do is, rather than keep this build here, I think I'll just move Groot2. I don't want to move it. I think I'll move it up here. Oh, okay, right, because that's a Nix store. Again, I can't move it, but I can make a symbolic link. So symbolic link this to Groot2. That file, what do you mean that file exists? Groot2? Oh! Look at this. And then I link the same thing. Okay, cool. And then if I run this, oh, I need to do this. Yeah, okay, cool. Got it. Awesome. So that means I can now move this. Cool. Two. So when you open it up, I've only played around with it a bit, so I'm not an expert by any means. But it looks like the way it works is you create an empty file, but you can't save it. If you want to save it, yeah, you get this warning. The way that I think you're supposed to work around it is you press this button. All files will be saved in the current state, continue yes, and then you basically create a project within which all your XMLs are stored. So I will, yeah, I'll just go ahead and store it here. Cool, okay. Save. So if I close this now, I'm sorry, did I not? There it is. Yeah, there's the project. So load project. Okay, cool. I don't know why it wasn't working. Let me always success. Let me delete this, and we can do this. I think this button. Oh, okay, no, that makes it vertical. This button? Yeah, this is the one that like reformats it. So if I save now, it should work. Hey, okay, cool. I don't know why it was being all weird earlier. Alright, so Groot2 works. Awesome. Now, if we want to go about designing behavior trees that we're going to use, the number one problem right now is these are the standard behavior tree nodes that comes with Groot2, but obviously Nav2 has their own nodes that they've implemented, and we implement our own custom nodes that don't show up here by default. So we need to add those. Now, I've done this once before. Let's see if I can remember. I believe you have to go to here. Cool. And I think you have to, this basically defines all the nodes and the input ports and the output ports. I'll explain those later. So I think, oh sorry, if we go to Groot2 and we press add node model import from file, cool. And we navigate to that file, oh, sorry, that's my dog. We go to Nova source, natural autonomous behavior tree. Yeah, here. If we open up this, great. So we've added in our custom ones. We can add in like custom actions now. It should show like the input port and output ports somewhere. Damn, how do I get it to do that? What is this? Auto range, that's fine. This one has check detected. That one has ports, no? Query position definitely has ports. Okay, so why is it not showing le port? Le port. What is le port? Maybe I just need to like connect these. No, this doesn't seem right. Oh, let's go. There we go. Awesome. Input output ports. Very, very cool. Nice. Input and output ports. Oh, wait, if I think about it, in the context of the grid tutorial, would I have already explained what a blackboard is? Probably not. So a blackboard, for those of you who've done computer science, you'll probably be familiar with the concept of a hash table. For those of you who don't know what a hash table is, think of like that dictionary class in Python. Basically, an array where values are indexed based on a key. In this case, that key is a string. So you have this hash table, this blackboard, that is shared by every node within the behavior tree. Every node has access to this blackboard and the variables that are stored within. And the way that you can access them is by specifying the key, in this case, time allowance or goal, and then you can get the value from that key, you can do something with that value, you can change it, set it, whatever. Now, I've done quite a bit of reading. Is this working? Dude, Chrome's not working. I want to kill... I want to kill Chrome. Alright. Rerun Chrome. Hey, okay, there we go. Oh, this is not what I wanted. I wanted this. This is a great website. I've read all of this today. Very good stuff. The thing that I wanted to point out, yeah, this. So Blackboard, it's like a key indexes into the Blackboard. You can store any type of variable, and they can store that value, and they can be shared between the different nodes. Now, one thing that I think is important to point out here, ports. So these ports here are not, how do I say this? They're not necessary. Basically, you might be thinking to yourself, if there is a blackboard, a way of storing every possible variable that the nodes use, why do you need to specify an input and output to a node for that blackboard variable if you can just access the entire blackboard within the node? Well, if you're interested in their argument as to why they include input and output ports, you can find it here. But essentially, they wanted to design this behavior tree library to be, I believe the term is self-documenting. So basically enforcing this use of input port and output ports basically means that, A, it's self-documenting, and B, you can use editors like this to basically give you this sort of useful information that at a glance you can tell what variables, what information this node is using. That's the only purpose these ports serve. Okay, so I was wrong about this. There is one other purpose these ports serve, and that is zero copy access. Specifically, so get input and set output, that is basically get value from input port, set value to output port, and those methods do not pass the pointer to the object that's stored in the blackboard, but rather copy the value over. So I believe that is one more significant difference between just accessing the blackboard directly, and I believe when you access the blackboard directly, you get the actual object rather than a copying of the value. So that might be one more reason why you would want to use a port. You can still use these get blackboard methods, can I find an example? There should be one over here, like this. Like you can still, blackboard set variables. You can still get variables directly from the blackboard, but it is recommended that you do it instead using these get input methods, such as these. Using these instead. So get input, that is getting it from an input port, rather than getting it from the blackboard directly. I believe they have a warning. There was like a warning somewhere where they don't like it. They don't recommend interacting with the blackboard directly because of certain issues. Oh, here it is. Yeah, don't use blackboards. All right, I've rambled. I should probably go ahead and show you guys how to, what to do with that file once you have it. So all of our, actually, I'll show you what the file is first. Let me go ahead. Code should be here. Let me show you what is inside this file that we've just made using Groot. Whoa. This isn't right. Oh, here it is. Cool. So this is the project definition, which appears to have the model that defines all the nodes. And here is the actual behavior tree that we made. This right here, this is the same thing as this. Load projects. Oh geez. Oh, can I? Oh no. Yep. So this is the same thing as this. It's a different way of looking at it. So what? Oh, wait. No, sorry. This is the tree model. This is what it is. My mistake. So this is the actual behavior tree. There are all these ports that have empty values. This funny thing. So what we do with this is we can go ahead and put it where we store all of our behavior trees, which is in here. What I think we should do is just go ahead and copy this file and just paste it in here. I'll go ahead and I'll just rename this like tutorial BT for now. Now, something you might have noticed is these behavior trees, they have the behavior tree tags. This one actually defines quite a few behavior trees, but you'll notice that they don't include the tree model. I mean, you can keep it if you want. Personally, I don't think there's a point in having this because the tree models are all defined in here, so there's no need to basically duplicate them in here. So I prefer to leave them out. And this is our behavior tree, and we can actually go ahead and run this if we want. It won't do anything. So I think before we go to running the behavior tree, I'm actually going to go ahead and design one, and then we'll run it. So actually, why am I even ending this? This is useless behavior tree. This isn't what I want to design at all. I guess, yeah, at this point, I'll actually take a moment to explain what I want to design, which is, actually, let me go ahead and open, oh yeah, if you want to open behavior trees directly from XML file without making a project, you can go ahead and, I think it's press this. Yeah, here we go. So you can go in here. Actually, yeah, let me go ahead and close Groot. Run it again. Sort of have a clean slate. So you go in here, go into where all the behavior trees are stored, and then in here you can do what did I want to look at? I wanted to look at navigate through codes. Continue. Oh, there are a bunch of nodes here. Alright, whatever. Loading files containing custom. Do you want to load all of them within? Yes. Continue. Oh boy. Oh boy. Right, cool. Oh, because I didn't load the models. Right, I closed Groot and then I reopened it, so I didn't include the node model. Alright, whatever. It like resolved it anyway. So this behavior tree is from nav2, navigate through poses with planning and recovery. My plan is essentially to take this behavior tree and give it, like, edit its functionality. So navigate through poses currently, you'll launch everything but launch, you'll open up others, and you have the option to drop a bunch of goals and then start navigate through pose, and it will go to each goal one by one. I want to add functionality that if it spots an AR tag, it will stop navigating towards the current goal, navigate towards the AR tag, and then stop once it gets within a certain distance. Once it stops, we can, using some logic, basically identify that this AR tag has been detected and then go back to navigating towards the original pose. So sort of like the initial poses define a search area, and then it will travel through that search area to those different points, looking for any AR tags. That's what I want to do. So, without further ado, let's get started. This nav through pose is probably quite out of date, so I'm going to go ahead and just delete it. Yeah. And I'm going to get a new one from the nav2 repository. It's in here. How would I find this? I'm going to go ahead and... Oh, where's mine? Am I missing a sidebar? Okay. The specific behavior tree I'm looking for is the one used by the navigate through poses BT Navigator, which is in the BT Navigated package. Behavior trees navigate through poses with pre-planning and recovery. Where is my sidebar? There we go. So let's go to, it's a BT Navigator, right? Now, BT Navigated behavior trees, and then said nav through pose, pre-planning and recovery. Did I click on it? There we go. Cool. Yeah, so let's go ahead and copy this. That's not what I want to copy. I just want to copy the name of this file, dude. Alright, cool. Let's go ahead and make a new file here. We're going to call it that. It's going to be empty. We're going to go ahead and just copy this. Okay, great. We're going to go ahead and open. It's not what I wanted. Open Groot2. Go ahead and add the node model. Ooh, are these node models out of date? Let's assume they aren't for now. Let's see what happens. Not what I want. I want to upload. Up one. Yeah. Okay. And then behavior tree, other. Is this the right one? Yeah, this is it. Great. Awesome. Wait, huge. Ah, okay, cool. I'm gonna So this shows you all the ports. This is a lot of ports. I'm gonna hide them for now. Cool. So what's happening in this behavior tree? Um, there's quite a lot going on here. And I think I'll actually, can I like, ooh, I can't. I want to like toggle, can I like toggle this so it hides everything below it? Create subtree. Oh, wait, that's so cool. Oh, look at that. Yes. Okay, good. This is what I wanted. This is what I wanted. Okay, after looking at this, it's quite a bit complicated for an introductory tutorial. So I think for now, I'm happy to keep this behavior tree as like a black box for navigating to a pose. And we'll sort of learn bits about the specific underlying implementations as we try and implement our own thing. So all we need to understand right now is this behavior tree is responsible for navigating through an array of poses. So let's get to work. If I want to, so think about the flow of logic here. So start at the root, recovery node. Essentially, this a recovery node, it is technically a fallback node, and a fallback node will essentially mean that, well, it's a special type of fallback node that only has two children. So think of it like an if statement, an if-else statement. So what's happening with this recovery node is it'll take this child. If this child returns failure, then it will take this child. But if this child takes success, then it won't run this child. That's essentially also what a fallback node does. I don't really know what the difference is between a recovery node and a fallback node, other than a recovery node specifically can only take two children. I think it's a little bit silly because fallback nodes react the same way. If any of the children return success, then the fallback node returns success. But if any of them return failure, then it goes to the next node, left to right. So you could replace this with a fallback node, and I believe it would function exactly the same. But I'm sure there's something I'm missing here because I refuse to believe that they made an entirely new node just for, I don't know. So let's go ahead. Right, the flow of logic here is going to try and navigate. Can I like select? Or what is this? Oh, that was the other one. So what it's going to do is it's going to try and navigate through the poses. If that fails, it's going to go into this recovery subtree. So I actually might go ahead and do recovery. And just leave that for now. So yeah, what's actually happening here? So sequence checks for controller recovery with help of a planner recovery. Checks if the goal has been updated. If the goal hasn't been updated, clear the cost map. Clear. Yeah, so what's this? Clear global cost map. Clear global cost map. Spin, wait, back up. And if none of these work, I believe that there's also, if none of these work, like there's a limit on the number of times it can retry. I believe. Oh yeah, 6 times. So if it tries to recover 6 times and it doesn't work, then it just fails. So we can go ahead and hide all that because hopefully our thing won't have to worry too much about recovering. So what's happening here? Selecting a controller. What is that? What is that? Behavior tree? Polygon? What is this? This is a action node, right? Yeah, only action nodes can be leaf nodes. So I have to go into here. And then what is the name of this again? Controller selector. Right, so what's happening here? Okay, so there's a callback. There's a construct. So this is the constructor. This is what happens when a node is created. They're just grabbing it from the blackboard, dude. No, don't do that. No, that's fine. Great, so it gets a node. I wonder what this node is. I'm not 100% sure what is the Blackboard quote-unquote node. I think it might be like when you launch the navigator and you go across to node list, there is a node for the navigator, like the BT navigator. So I think this is what it might be referring to. But what's happening here? Gets the no callback, gets input from the topic name port. Topic name port, which is controller selector. Yada, some random subscription stuff. Creates a subscription to what? To controller selector. Okay, cool. What is controller selector? This behavior always uses bus controllers using topic input. Okay. Selected controller output. Got it. And the default controller is the follow path controller, which if we go, is that an actual, if I go to here, is that going to be an actual controller, follow path? No. Default. If default controller is empty, otherwise. What is this then? Default controller, follow path. It looks like something from a parameter file. Follow path. Controller plugin. Follow path. Ah, okay. So we've defined a controller plugin, which is actually just this. Okay, interesting. Cool. So that's the controller passing in. So controller selector, I'm guessing that there is a topic when you run the nav2 stack that is publishing the controller being selected, which is coming from here. And then I imagine that planner selector is going to be the same thing, but it's going to be for planner. Rate controller, what is this? So this is just, what is this? This is a recovery? Oh, sorry, let me close these again. So recovery node. So a recovery node, the way to look at a recovery node is basically the thing on the left is what it actually wants to happen. And then the thing on the right is what happens if the thing on the left doesn't work. So we don't really care about this. So if you look over here, the thing on the right, would a planner recovery help, clear, global cost map? This is just a recovery. So we can actually, I'm going to go ahead and collapse that as well. Recovery 2. Great. Can I rename this one? Recovery 1. Right. What? Can I not? Oh, no, I can't. Alright, whatever. Cool. So that's just recovery. We don't really care about that. So it selects a controller, it selects a planner, it removes past goals. What is that? Remove past goals. So what do you do? So you have a constructor that does nothing. Okay. You have an initializer, so you get, let's go ahead and toggle this. So you have 4 input ports, 1 output. You take in goals and you take in a radius. Interesting. What do you use that radius for? So radius via point. Okay. You get transform buffer. I don't know what that is. You get node, transform tolerance, deconflict. Oh, interesting. Okay. Was that to do with this? Interesting. Okay. I wonder what this method does. I won't look at it for now, but looks like it's just getting the base strength. And then we have the tick method. Yeah, so this is what happens when the node is constructed. This is what happens when the node is initialized, and then on tick is what happens basically, when the behavior tree is running, and then it ticks the node. So, oh no, sorry, initializes cold has to be cold here. Okay, cool. So initializes, creates goal poses, gets the input goals from the port. Current pose. That was gotten when it was initializing? What does current pose come from? Oh, it created it. Sorry, my bad. Goal poses. Okay, interesting. So if you can't get the current pose, then failure, so error handling. So if we're here, we've gotten the current pose. Now we're calculating the distance to the goal. If the distance to the goal is greater than this radius, then goal poses, while go goal poses 1. So the distance to the goal will be this. Wait, what is happening here? Goal poses. So he gets the first goal pose, finds the distance between where the rover currently is and where the first goal pose is. If it's greater than this radius, then it just passes the goal poses to the output, so it doesn't do anything to the goal poses. But I didn't see this for some reason. Goal poses pose arrays. Okay. Not sure what this does. I guess I'm gonna have to find out. Oh, I get it. I get it. Okay, right. So I was quite confused. I was like, why does an action for removing past goals take in a radius value? And then I realized this is assuming that the footprint, so when I refer to the footprint of the rover, I mean like just like the size that the rover takes up in the physical world. So this is assuming that the footprint of the rover is circular. So it's basically just checking if the distance to the goal is within the footprint, then you have arrived at the goal and you can erase it. Got it. So this is how we remove the goals that we've reached that have, entered within our footprint. Got it. Okay. So that's what this action is doing. Awesome. And remove the goals that we've passed and then compute path through poses. So what this is going to do is going to take in the goals, it's going to take in the plan, it's going to output a path. I don't think there's any point in looking at the implementation. I think that's pretty self-explanatory. So I'll skip that for now. So we select our controllers, our planners, we remove any goals that we've already gone over, we compute a path, and then if everything goes according to plan, we follow that path. Which again, I think is pretty explanatory, yeah? Takes in the controller and the path, and then I assume just follows it. And again, yeah, this is just a recovery. So we can go ahead and create another subtree here. Call this one recovery. Great. Okay. And let me go ahead and link it. Great. I never intended to go through this behavior tree in detail, but we have. So there we go. So how would we introduce our changes? So what I want is, I guess this is fine. Navigate. I think, ooh, I'm gonna make a new one. An action, a condition. This would be a condition. Basically, what I want is if AR tag detected, go down this separate tree. That's what I want it to do. You know what? I'm just going to make nodes and it will just go ahead and auto arrange them. So I only want it to go down this behavior tree if we're searching. So let's go ahead and, oh no, root has to go to one thing. All right, let's say it goes to this condition for now. I want to make a new thing. It's going to be a condition. It's going to be AR tag. And I'm not going to give it any ports for now. Because I just don't know. I don't know what ports this thing needs. Condition. Let's control. Condition. Cool. So AR tag detected. Now, if this returns success, well, before we think about that, if this returns failure, then I want the behavior tree to go to here. So if it returns failure, it needs to go to the next one, which means a fallback node. Because a fallback node, yeah, a fallback node. So I guess I could do a recovery node, but that's not the intended use, so I think I'll do a fallback. Is there a fallback is not an action, it is a control. So I'll just do I want to do a reactive fallback? Reactive, because I want it to keep ticking. So basically, two options here, fallback and reactive fallback. A fallback node will tick child 1. If child 1 returns failure, it'll go to child 2, and it will never tick child 1 again until it goes through all the other children, which is not something we want. We don't want it to tick AR tag detected, and then never tick it again. We want it to keep ticking it over and over and over. Every time that this node is ticked, we want it to tick through all of its children again, which is what a reactive fallback will do. So let's go ahead and get rid of this bond, and then put it in here. So reactive fallback, if AR tag returns failure, it'll move into the navigating through the poses it was given. If this returns success, it will immediately return success from here, and then it'll go up again another level. So where we want it to go up to, probably into something that when this returns success, it goes to the next one, which would be a sequence. And again, I don't want it to, I want it to keep retaking this one, so we'll do a reactive sequence. So we'll go ahead and break this bond. This can go here. This can go here. Let's go ahead and reformat it. So, oh geez. Okay, cool. So if this returns success, we're gonna go into here, and in here is gonna be our navigate to AR tag. Now, how do we want to do this? I need an action. I need an action to generate a goal for an AR tag. Compute, so basically compute path through pose, but something that does that. Compute path to AR tag, maybe? Oh, it's basically going to be a duplicate of this. It's going to be a duplicate of this at this point. The only difference is the goals. How do I'm basically going to need another navigate tree, but see, this tree uses goals. I'm going to need like another Blackboard variable. It's called AR goals. But the question is, how do I define a logic that generates and populates AR goals? I know what needs to be done, I just don't know where it needs to be done. So I think I should have, I think I will have an action. I'm going to have an action here. Let me make it. And this one's going to be, I'm going to say compute AR tag and then action. Hey, compute AR tag goals. So if we see an AR tag, we compute the AR tag goals, and if that returns success, then I'm going to go ahead. Can I? Alright, is this the same? And then what do I want to do? I want to do this. Alright, let's compare. Control select the right controller. Yep. Recovery node, reactive sequence. Yep. Great. Okay. Toggle you, and I just want to change this to be AR goals. AR goals. And I think that's the only thing we'll have to change. Oh, but I want it to... but I also want it to... Once it arrives the AR tag, it doesn't... Like, what's to stop it from continuously, like, seeing it and setting it as a new goal, right? Like, there needs to be something that goes once... So I need to change this remove past goals. I need something that once it realizes it's arrived at an AR tag, it doesn't try to go back to it. So let's go ahead and make a new, this is going to require a new action. I'm actually going to go ahead and make ports for this. So we're going to have an input. This is still going to be goals. We'll still have a radius. What the hell, I'll have a frame, why not? We'll go ahead and still, yeah, I'll copy it all. Robot base frame, and then we're going to have output goals, and we're going to have, let's just call it visited goals. You've already visited these. So you're an output, and you're an output. The rest of these are fine. Model name. Oh, what do I want to call this? Remove past AR tags. Oh, yeah, I can name the port that way. Yeah, I guess fine. Sorry, yeah, I can name the port input goals, but I have to name this different. Yeah, cool. So let's go ahead and put that in. 7. Output goals, and let's go ahead and just call it visit. Let's remove that. Remove, delete. Okay. So AR goals, path, that's fine to overwrite. Okay, rest of this is fine. And recovery, yeah, that's fine. Yep, cool. Anything here that's referring to goals? Nope, all good. So these recovery trees are good. There's one other thing I have to change. So, visited AR goals. Where do I want that to be used? Where do I want it to be like? It sees an AR tag and it checks, hey, have I seen this before? Here. So you, my friend, not you, AR tag detected condition. You need a port. It's going to be an input. It's going to be visited AR tags. No. False. Right. The model is used in the following tree. That's fine. Override it. Visited. On the port is just visited goals. Okay, my bad. Visited goals. Yes. And then that's going to be the value. So it's going to take that as an input from the blackboard. And I'll make sure when I'm implementing the condition, if the AR tag, if the ID of the AR tag is detecting is already in this array, then this will return failure. Good. So this will go find the AR tag. I'll give it a bigger radius because I don't want it like running over the AR tag. Let's just double it. Let's double it. Cool. So let's go ahead and shrink this down. And I'm gonna go ahead and create. Do I want to create a subtree? Let's look at what's happening. We're navigating through the poses we've been given through arbors. But the moment we see an AR tag, right, and we're constantly checking, are we seeing an AR tag? Are we seeing an AR tag? It's returning false, so we go here. The moment this returns success, or we're seeing an AR tag we've never seen before, we go up here, we compute the AR tag goals. Now what's going to happen here is that we're going to subscribe to the AR tag detection topic, and we are going to take the AR tag we're seeing, convert it into a goal. So this needs to be it then. This needs to have an output port for AR goals. That's what needs to happen here. Yeah, right. Does it need to take an input? I don't believe so. Nope, probably not. That'll be fine. So let's go ahead, not here. This is an action. So you want to take an input. Wait, no. You're going to be an output. And that output is going to be AR goals. Wait, is that correct? What's the... I'll just call it output goals. Output goals. And the name, yes. And the name is going to be AR goals. Great. Cool. So, we found an AR tag, we convert it into a goal, like a we convert it into a goal, into a blackboard, and we start navigating towards it. It's the same pose as this, it's just instead of the other poses, which should be untouched, we are going to go through this to navigate to the AR tag, and then once we get to the AR tag, we are going to remove it when we're like double the distance away, and we are going to note its ID so we never go to it again. And that should be it. Dude, I think we're done. At least with designing this behavior tree. I'm going to go ahead and navigate. Great, look how clean this is, dude. Great. So, this is our behavior tree. If I save this, how does this look? So, this one? No. Where's the file? Wait, I'm editing, this. Here it is. So, behavior tree, recovery, yeah, here it is, it's all here. Description of node models. I actually need to keep, well, I don't need to keep them. Maybe I do. I just need, AR tag detected. Okay, I guess I'll figure this out later. Cool. So here's XML. We're good to go. Now we just need to implement AR tag detected, compute AR tag goals, and remove past AR tags. These are our 3 custom ones that we need to implement. Let's get to it. All right.